Hello, this is Dr. Oz. In this video, I would like to talk to you about how to choose the right approach or model. And to do that, we need to measure the error. And these are the three main ways to measure error: MAD, MSE, and MAPE. So mean absolute deviation, basically we look at the error or deviation, which means that our forecast versus minus actual, or actual minus forecast, either way is fine. And then take the absolute value of that. So error for each period I, you take the absolute value of that, and then add it up. Mean squared error, basically you look at the errors and then you take the square of that and you add them up. And then mean absolute percent error, basically you divide your absolute values of your errors, add them all up. Maybe I should put the summation symbol in front of them. Add them all up for every period and then divide by the average of your forecast. I will show you all these things in an example, but let me just first in this video talk about how to calculate this. Again, MAD is adding all your actual minus forecast values and then divide by n. So if I want to make it more specific, period I, actual I, forecast I, and you divide by n. And for mean square error, MSE, basically you add up all the forecast errors, which is actually given at the top, actual minus forecast. So maybe I should define here error as actual I sub I minus forecast sub I. So then you basically here look at your at E sub I errors and take square of that and then add it out over I divided by number of periods. Okay, and then for MAPE, what you do is mean absolute percent error. You add over every period absolute value of your error divide by actual value over I periods, and then you divide this by I here. You divide this by number of periods. Okay. Again, when I show you this in Excel, you will see that it's much easier. So this is how we measure error. Also, before I go to Excel exercises, what I would like to show you is that how to do association rule instead of excuse me, instead of using the four approaches that we use so far, like trend approach, moving average, naive approach, and weighted moving average. I could use association rule, and association rule starts with the trend projection, which is your basically simple linear regression line, which is a plus bx. This is your slope and this is your y-intercept. So b is your slope and this is your trend line. Okay, so if your data, let's say demand data time is like this, basically this is the best line that you can find, and this is your forecast line, which is gonna be a plus bx. B is the slope, a is the y-intercept. Okay, all right, so let me show you how it works. Also, we call this regression or least squares method. What we do is we look at the real data. These are the stars, and then we draw a linear line that minimizes deviation, which is the vertical distance. For example, from the star point to here, the vertical distance is this. This is the vertical distance. This is the vertical distance. This is the vertical distance. and so on. If I add those vertical black lines that I draw, vertical distances, and add them up and minimize them, that's your best line, or least squares method. That's your trend line, or simple linear regression line. Again, we talked about this before, but we got to consider the seasonal variations as well, because if there is a seasonality, let's say your winter sales are low, and then the sales goes up in summer, goes down in winter, goes up in summer, and down and up and down and up and down. So you cannot really, if you have seasonal like this, the trend line cannot explain everything. So you need to consider these peaks and valleys, which we call seasonality. Okay, seasonality, and I will show you how to deal with that. So this is your pattern number one, which is your trend line. And this is your pattern number two, which is seasonality, okay? If you have cycles, which is more than a year, as we talked about in the previous video, then things are a little bit more difficult, and you need to understand other independent variables x sub i's, such as, again, this could be, example could be inflation rate, business cycles, and so on. You need to consider those in your multivariate analysis, or instead of using simple linear regression, maybe you will use multiple variables to describe or forecast your dependent variables. So again, this trend approach is also can be explained as considered as an associative forecasting if you think that there's a causal relationship. What do I mean by that? Let's say you have independent variable x, or variables, it could be x sub I, and if you think that these x independent variable or variables cause your y variable to change, then you need to use associative forecasting. What does it mean? For example, if you think that if you spend more money in marketing, if you expect to have higher sales, that's your independent variable, marketing spending, or R&D spending, or transportation costs, whatever it might be. So you can use those as independent variable, and then you forecast your demand. Okay. So the most common technique here is linear regression analysis. Okay, linear regression analysis. All right, so linear regression analysis is no surprise. It's your trend line. Basically, we talked about this already. Your forecast will be y-intercept plus bx. So this is your slope. And again, this is your y-intercept. So, and this is your independent variable. All right. Once you make your forecast and then calculate your errors, you can draw a tracking signal line, a graph, which you can look at your errors and see whether they exceed in certain thresholds. And these are statistically significant thresholds. Let's say here, if you see this situation where your forecast errors is beyond so much error, I will talk about all this in an example in Excel. So this tells me that world has changed. In other words, I need to update my model. My forecasting model is not working anymore. Okay. But if the error is like here or here or here or here, if your error is within certain bounds, statistical bounds, we say that this is a normal. This error is randomness, and it's a noise factor, so that's okay. But if your error is significantly big statistically, then you may need to reconsider your approach to see whether your forecasting is accurate anymore. That's it for this video. Until next video, enjoy supply chain management.